Okay, hypothesis test for the mean, worksheet number 1. So we have a company right here, and they have a goal of developing a battery that would last more than or over 300 minutes. Okay, and so we got a sample size of 12, and then we got a data set right here, and then we are being asked, is there evidence? So that question, is there evidence? So it's telling you you are going to do a hypothesis test, and if you look at the problem, there is no population standard deviation, SD, and so you kind of know you are going to be doing a T model here. Okay, so let's start with the hypothesis, and let's start with the null. The null would be, again, the null is saying there's no change. Okay, and if there's no change, the mean battery life is still 300 minutes. So let's write that. Okay, and the alternative is going to be, this is over, so this is greater than. Okay, so the alternative would be the mean battery life is over 300 minutes. So let's go to the part 2, assumptions and conditions. And so there's a randomness, independence, less than 10%, and the nearly normal condition. Let's write that. So the 12 samples were randomly chosen. Each battery life is independent. The 12 sample is less than 10% of all batteries manufactured. And then we get to number 4. Okay, so we need to do some work here for number 4. It's the nearly normal condition. And so we got the 12 data here, and we need to encode that in our calculator, and I've already encoded it. Okay. Okay, so I've encoded the data. Again, I told you before, as soon as you finish encoding the data, you always want to do a one variable stat, just to know the mean and the standard deviation. Okay, so one variable stat, and it's going to be battery life, hit OK. Okay, so the mean is 306.25, and the standard deviation of the sample is 29.31. Okay, so just keep that in mind. Let's look at the graphs. Okay, so this is a sample mean, and the first thing we need to find out is if there is outlier in the data, and to find that out, we need to check the box plot. So that's the first thing we need to check. So menu, box plot, so check box plot. Okay, so the box plot, there is no dot here. A dot would mean there's an outlier. So okay, outlier, no outlier. We check outlier and we didn't see any. Okay, and so we now do the histogram. We do menu, plot type, we change it to histogram. Okay, so the histogram, there are a lot of gaps in here. It's because the width of each of the bar is too small. Okay, and we need to adjust that. Okay, so if you remember, the standard deviation that we had was 29. Okay, so maybe let's use that number. So let's do plot properties, histogram properties, bin settings equal bin. See, it's 5 now, and 5 is too narrow, and so we increase it to, let's just say, 29. Okay, we need to zoom out so we can see the data. Okay, so this is the histogram now. It's unimodal, and you have to remember that there are only 12 data sets here. Had there been more, this would probably have been unimodal and symmetric. So you don't have to be really strict. Okay, so if you see it's unimodal and this is roughly symmetric. Okay, so let's go here and let's write that. Okay, so I'm going to say the 12 sample is small, but the histogram shows unimodal and roughly symmetric. Now, sometimes you're not comfortable in saying roughly symmetric, so you're just going to say unimodal and with a little bit of skewing left or right, depends on your data, and you're just going to say we proceed with caution. Okay. And so I got all 4 conditions here, and then I'm going to do the final statement of the assumptions and conditions. I'm going to say conditions met, we assume T model and perform a one sample mean T test. Okay. Part 2 would be the mechanics and the conclusion.